Okay, so last video, I took my still lab 1, I guess, and I got my triangles all animating in this hypnotic way. And just a quick little recap, we're doing that because now we've got a uniform called uOffset, which I'm assuming is number 1, but we query the graphics card and ask what is the location that OpenGL calls it. What kind of ID does this offset have? Does this uniform have? And then we can set variables on this uOffset and access them in both the shader, both the vertex and fragment shader, without without having to change our vertex data. So the next logical question is, okay, great, you've got these 4 triangles spinning around. What if I want them to spin at different rates? So shockingly enough, it's actually like incredibly simple to do that. So again, quick refresher. Right now they're just kind of spinning with sine and cosine. So the y is doing this, where timestamp goes up by milliseconds. So every 1/5 of a second, they do like 1 over pi or whatever it is of a sine wave, and then times 0.25 to kind of shrink the height of that sine wave so they don't go way off screen. And then x is doing much the same thing, but left to right. And once you add the left to right, whiff, whiff, and the up and down, woof, woof, then you end up with the whooshy, whooshy, like that. And in order to get them to all do kind of different things, again, like I said, it's quite simple, more simple than you would think. Or hopefully, if I've done a good job with these videos, exactly as simple as you would think. So let's again remind ourselves what happens if I do this. Draw triangles 0 to 3. Again, that's saying draw from 0, draw 3 vertices. 2 floats, 3 floats, that's draw 1 vertex, 2 vertex, 3 vertex. And so I'm drawing this. I set a uniform and then I draw this. Now, what happens if I set a different uniform and draw this? Or set a different uniform and draw this? So, just with me saying that, I hope you can see the power of uOffset, or of uniforms, is that I can draw some chunk of my vertices, or some of my models, some of my objects in the scene with some uniforms, change the uniforms, and then draw more objects. So that's exactly what we're going to do. So instead of drawing 0 to 12, I'm doing 0 to 3. And then I'm going to just do this again, but draw 3 to 3. Or, sorry, 3 and 3. So mode, what? First and count. So start at 3 and draw 3 of them. So there's our second triangle again. But I basically just send the same uniform twice. Well, what if I divide by a bigger number? You can see immediately, done. We've animated them separately. But there's a bit more to this lesson than just doing this. So let's put our other 2 triangles back. We'll divide this one by 600 and this one by 800. And then again, we need to tweak our little, so this one starts at 6 and this one starts at 9. And there we go. We are drawing all 4 of our triangles with 3 vertices starting at 0, 3 starting at 3, 3 starting at 6, and 3 starting at 9. Again, whenever you're doing this work, picture your buffers in your head, and 3 starting at 0. Maybe it would help if I, oh my goodness, I'm killing this marker. Yeah, 3. If I put each vertex, gave it a little separator. Whoop, whoop, whoop. So draw 1, 2, 3 starting at 0. Draw 1, 2, 3 starting at 1, 2, 3. Or so picture this in your head whenever you're doing your draw arrays, and the numbers you plug in will start to make more sense. So the next kind of, excuse me, I need to drink more water. The next part of this is, hopefully, if those among you watching are seasoned programmers, you'll see what I've written here, and you'll immediately be itching to, what's the word? Abstract this. I am too. So let's do that. So we're going to start, obviously, I'm doing the same thing 4 times, but with a little bit of a difference each time. So when I see the same thing 4 times, what that looks like to me is prime use case for a loop. So I want to do for I less than 4, and then I do not need a length or anything, but thank you, VS Code. So let's do something 4 times. So what do I want here? I want some new sign thing, which for the first one will be 200, and then 400, and then 600, and then 800. So to me, that looks like, const, I don't know, it's kind of like an angle because I'm passing it to cosine or whatever. But I don't know, I guess I can call it like, yeah, whatever, const theta is like 200 plus, in this case it was 200 plus 0, and then 200 plus 200, 200 plus 400, so that's 200 plus 200 times I, or 200 plus 200 times I plus 1. So that's my new theta, and then that means that my offset is going to be the 2-dimensional vector of timestamp divided by theta. Actually, I guess it's not even theta, it's like a, so really, if I want to call it this theta, what I want is this timestamp, but I'll keep it simple. So timestamp over theta, and then timestamp over theta. So that's my new offset. And then I call GL dot uniform to FP, new offset, and pass in my offset, my little array. Oh, but I also want to, silly me, I need to call cosine and sine on those. Maybe I'll call this like multiplier. And then math dot cos and sine. And then shrink those by a quarter. There we go. And then in here, same thing that I did with my 200, right? I'm just going to do a quick little mental math. Draw arrays, start at triangles, draw with triangles. And I'm going to start at 3 times, so this is 0 plus 3 0 times, 0 plus 3 once, 0 plus 3 twice, and 0 plus 3 3 times, aka 0 plus 3 times I, which is literally just 3 times I, but I think writing it like that makes it really clear. And then I want to draw 3 every time. And that's it. Now, that replaces all this. Ta-da! So you can see loops and that sort of thing are your friend. We can take this a step further even. I think you're going to see pretty quickly where I'm going with this. If we want to, we could pull out a function. Draw a triangle or something, and then draw a triangle number n. And then that one we can just kind of do this. Yoink. Yoink. And then instead of I called it n. Draw a triangle n. And then in here I can just call draw a triangle I. So whoopsies, except I broke it. This one also needs the timestamp. There we go. So hopefully that makes sense. So yeah, how long have I been going here? 9 minutes? I think I'll cut it here, and then I'll do another layer of abstraction after this. And we'll go over what happens if we have like funky formatted buffers.